OK, believe it or not, that's actually it for DNS. If you know the two main ideas and you follow the walkthrough for how it works, that's basically all the intuition behind how this protocol works. So the rest of today is really just figuring out how to implement this in code. Instead of using nice little speech bubbles in English, we need to figure out how to make this a protocol that works and works fast and is scalable. So lots of implementation details coming up next. So the first thing we have to ask ourselves is what type of layer 4 protocol we should use. So remember that when you built that networking stack with all of the layers, you had two choices at the transport layer. You could have chosen TCP, which gives you reliability and makes sure that packets are resent if they don't arrive, and reorders packets and all that good stuff. Or you could use UDP, which doesn't do any of that stuff. So which one do you want? Do you want TCP or do you want UDP? Well, at first you might think TCP is better, but DNS is actually one of those cases where UDP is better. And the reason why is because DNS has to be really, really fast. Think about every time you type a URL into your browser and press enter. Every time you do that, your computer has to do a DNS lookup. If you click on a link to go to another website, guess what? That's another DNS lookup. If that website has to load images from other websites, even more DNS lookups. So when you're browsing the web, you're doing tons of DNS lookups all the time. So it's very important that DNS lookups are as fast as possible. If DNS is slow, the entire internet becomes slower because it's such a core piece of the internet. So in order to make DNS as fast as possible, the designers chose to use UDP because it helps us avoid that three-way handshake. Remember that in TCP, you can't start sending data until that SYN, SYNAC, ACK handshake is over. By contrast, in UDP, you can just immediately send the question, and you don't have to wait for the handshake. So that's nice. It helps us save some time, and it affects performance for basically any internet application you're using. And in case you're worried about packets getting reordered, that's usually not a huge deal. UDP or DNS requests usually fit inside one packet, so there's not really any need to reorder packets. You send one packet out, and you get one packet back. And in case you're worried about packets getting lost, if you send a packet using UDP and you don't get an answer, just send it again. So just do the reliability thing yourself and resend packets if they don't show up. So you still get some level of reliability, but by avoiding that three-way handshake, you make things a lot faster.